Well, good afternoon, everybody, and thank you for joining us today. My name is Kathy Schultz, and I am the Water Education Specialist with the California Department of Water Resources, and I would like to welcome you to our first Water Wednesday. The mission of the California Department of Water Resources is to sustainably manage the water resources of California in cooperation with other agencies to benefit the state's people, and protect, restore, and enhance the natural and human environments. Today and for the next 5 weeks, we will be exploring one of those natural environments, the Sacramento-San Joaquin River Delta. And we are joined today by Nicole Kwan. Nicole is an environmental scientist with DWR who does research on native fish. Before I turn things over to Nicole, I just want to go through a few logistics. If you are joining us on Zoom, we are turning off your cameras and muting your microphones. But we would really love to hear from you. And so you can pose questions in our chat box. And we will do our best to answer your questions. We so far have over 50 people joining us, so I can't promise that we will get to all of them, but we will definitely do our best. I really want to ask you to please remember to just use the chat box for questions. If you are using it inappropriately or spamming the chat, I may have to remove you from the program. The good thing is you can still join us and watch us on YouTube, but the only way you can submit questions is through Zoom. And so if you're joining us on YouTube today, the chat feature is not available. If for any reason you have to leave the program early, but would like to watch it later and find out how everything ends up, it will be posted on our YouTube channel, California DWR. Lastly, if you are under 18 and you have joined Zoom with your full name, if you can go into the change name feature and just use your first name and the first initial of your last name. That's the best way to use Zoom, especially if you are under 18. And with that, again, I would like to welcome everybody who's joining us, and I'm going to turn things over to Nicole. So Nicole, it's all yours.
Great, thank you. I'm just going to get my screen up for all of you. All right, so hi to everyone tuning in from your homes. My name is Nicole Kwan. I'm an environmental scientist at DWR, and I'm here today to talk to you about native fishes of the Sacramento-San Joaquin Delta. And as Kathy mentioned, we really encourage questions, so I'd love to hear any questions or comments you have on my presentation today. So don't be shy about using the chat box. So let's start off with where the Sacramento-San Joaquin Delta is and what it functions as. So the Sacramento-San Joaquin Delta is located in California, just east of the San Francisco Bay. It's the largest estuary on the West Coast and serves as the meeting spot for the Sacramento River from the north and the San Joaquin River from the south. These two rivers combine in the Delta and flow out the San Francisco Bay to the Pacific Ocean. Now take a look at this map and this picture of the Delta. What do you notice about the different features that you see? What I see is a very complex maze of waterways. And not only is the Delta complex, but it's critically important to California as it provides 2/3 of residents and millions, provides drinking water to 2/3 of residents and millions of acres of farmland. The Delta also provides habitat to a host of important fish and wildlife species. And what we'll be talking about today are some of the fish species that call the Delta home. And just to be clear, there's a lot of different fish that swim around in our Delta, but we're going to be talking about what we call native fish. And so these are fish that's ancestors would have been in the Delta just as well before humans built cities like Sacramento and San Francisco. And so those fish that have been living in the Delta for a really, really long time are what we call native species. And there are about 28 different native species swimming around in the Delta today. Now, the native fish that live in our Delta have to be strong enough to handle big changes. And this is because the delta is complex and can experience extreme shifts based on how much rain and snow California gets. So if there's a lot of water, the rivers feeding the delta run high and can flood out into areas of land, essentially creating some extra fish habitat. However, California can also see extreme droughts. Take a look at this picture here and notice how many people are walking around out in this dry, sandy landscape. Now that area usually would be covered by a lake, but you can see the lake's really far back in the background. So this is during one of the critical drought years in California. And you can notice just how much less water there is than normal. When there's less water, the rivers also are running lower and there's less habitat available for fish to take advantage of. The amount of water that's in the rivers also causes important changes in water temperature, quality, food availability, and competition, all of which affect fish living in the Delta. So because native fish have had to live in this complex changing system, they have changed or adapted in ways that help them live in this environment. One example of an adaptation is migration. So many of you may be familiar with seeing birds or geese flying through the sky and migrating from one area to another. And fish do this too, we just don't see it as easily because they're underwater. There's a specific kind of migration that a lot of fish make where they move between areas of freshwater and saltwater. And scientists, we call this anadromy. And that basically is just the short word for migrating between different areas of fresh and salt water. Anadromy is a powerful tool because it allows fish to take advantage of different habitats and choose the best one for different activities, such as growing up, eating, and mating. For example, the ocean is a great place for fish to find lots of food, but freshwater streams have less predators and better places for fish to lay their eggs. By being anadromous, a fish can increase their chances of success during different parts of their life cycle. One great, well-known example is the native Chinook salmon, which is my favorite fish. These salmon can be found all the way from Alaska down to the Delta, making the Delta the southernmost portion of its population. Salmon complete amazing life cycles. They start as eggs buried in the gravel and then grow up in the river until they are ready to head to the ocean. Can you see in this life cycle diagram how they start as small fish with their egg sacs still attached to them? After they grow up, these salmon will travel sometimes hundreds of miles through the Delta to reach the ocean. And while they do this, their bodies have to completely change so that they can survive in salty water. When reaching the ocean, they usually spend about 2 to 4 years eating and growing. And then they turn around and using just their nose, smell their way back to the exact river that they were born in. When the adults head back to fresh water, they stop eating and only focus on their mission of making it back to their home river. They have to swim against the current, which is hard and exhausting, and sometimes this journey can take a long time. Can you notice in this diagram how the adults change colors when they leave the ocean and return to freshwater to spawn? They kind of take on this reddish hue that they didn't have when they're in the ocean, and they're more silvery. Then these adults, once they get to their stream, use their last energy to build a nest and find a mate. After they lay and fertilize their eggs, the adult salmon die and their bodies provide nutrients for other animals and plants in and around the river. By having this anadromous life cycle, salmon are able to take advantage of different habitats for different activities. Another example of an anadromous native fish are sturgeon. Sturgeon are amazing fish that first appeared in the fossil record 200 million years ago, during the age of the dinosaurs. Salmon, by contrast, only appeared 6 million years ago. Sturgeon can reach up to 9 feet long and are covered in unique bony plates called scutes instead of scales. Maybe you can notice these rows of scutes along the top of the sturgeon and the sides and stomach. This sturgeon is a green sturgeon, which is one of 2 native sturgeon to the Delta. Green sturgeon complete life cycles similar to salmon, but they spend more time in the ocean, sometimes 10 to 12 years at a time. And this is because they're believed to have maximum lifespans of 60 to 70 years, whereas salmon only live about 4 to 7. We have another species of sturgeon called white sturgeon. These spend less time in the ocean and spend more time in areas around the San Francisco Bay and Delta. But they have much longer lifespans that historically could have reached up to 100 years. You can see here 2 field staff of DWR handling an adult sturgeon that we caught in one of our fish traps. And they're pretty big, so it requires multiple people to move these fish and return them back into the channel. Then we have the much smaller Delta smelt. You could easily hold this fish in the palm of your hand. These fish don't get much longer than 4 inches, and they have short 2-year lifespans. They are unique Delta fish, as they are only found here in the Delta and nowhere else in the world. Unfortunately, this makes them very reliant on the Delta for their survival, and human changes to their home have made life hard on the Delta smelt. And there are currently so few left in the wild that they are considered at risk of disappearing forever, which is also known as going extinct. They are also an example of a fish that migrates between fresh water and water that's a little saltier, but not nearly as salty as the ocean. So they complete their entire migration right within the Delta itself. And because they only go between areas that are fresh and areas that are a little bit saltier, they're considered semi-anadromous fish. They like to migrate to the saltier areas of the Delta during the summer because they can find better food and cooler water temperatures. Then in the winter, they like to go back to the fresher parts of the Delta to spawn. Another way that fish adapt is by having bodies that can help them succeed in their environment. While the fish in these photos are not from the Delta, they help illustrate how fish can have lots of different body types and features. Can you, just looking at these, make any guesses about where they might live or what they might eat based on their bodies? Here are a couple ideas. The way a fish's body is shaped and the special structures it has is called morphology. As you can see, the morphology of a fish can tell you a lot about where it likes to live and what it likes to eat. For example, the fish on the bottom that's very flat is a fish that likes to stay on the bottom on top of sand or anything that they could nestle themselves into and blend in. But because they're flat on the bottom, they have a special adaptation where both of their eyes are on one side of their body. So this allows it so that when they're laying down flat, they can still use both their eyes to see any dangers coming or to find any food. Now, a local example of these types of different body types is the Delta's native minnows, such as the Sacramento splittail and the Sacramento sucker, which have streamlined bodies to help them efficiently swim upstream against the current to reach the habitats that they like to spawn in. Another example is how some fish have mouths on the bottom of their heads, which are called subterminal mouths, and help them take advantage of food that lives in the mud. Here's a fun video of the mouth and special large lips of a Sacramento sucker. And they like to use these special lips to roam around on the bottom and scrape algae off of different rocks and features. Unfortunately, humans have changed the Delta in several ways, making the system look less like the home that these fish adapted to. This has allowed new fish that are brought into the Delta from other water systems to be successful, even though they do not have these special adaptations. These fish that do not have ancestry in the Delta are called non-native or invasive species, and they can compete with native species for habitat, food resources, and they can sometimes prey on some of the native species. So they've become a bit of a problem for some of our native Delta residents. Now, because of all these changes to the Delta, scientists are working hard to understand how our native fish are doing and what we can do to help. The project I work on studies fish in a large floodplain called the Yolo Bypass near the city of Sacramento. And a floodplain is just an area of land that the rivers can spill out onto when water levels get high. In this picture, see if you can find the ripple running through the water in the middle of the photo. It's right here, and it's underneath that is what's called the Fremont Weir, which is essentially a big mound of dirt that runs for miles along the Sacramento River. And what it does is it usually helps keep water back and keep it in the river. However, engineers designed it so that when the river got too high, it would flow over that weir and into the Yolo bypass. And this is an important feature because this means that the Yolo bypass, which is usually just farmland and some nature preserves, is what ends up flooding instead of the city of Sacramento. In the Yolo bypass floodplain, we study how native fish use the area for migration, eating, and spawning. In these pictures, you can see some of our main fish sampling methods. Have you ever seen traps or nets like these before? Do you have any questions about them? I just want to remind everyone that you can submit questions as you're watching this in the chat room in Zoom. By using these sampling devices, we have discovered that native fish really like the Yolo bypass floodplain because a lot of food grows there, which helps feed juvenile fish. Also, a lot of adult fish like to use the underwater plants as a place to lay their eggs. Now, it's not surprising that these fish like this habitat, since many native fish evolved to use these floodplain habitats historically. So flooding is actually a pretty good thing if you're a native fish. Unfortunately, due to human development, a lot of floodplains that used to exist in the Delta are now gone. Since much of these former habitats have been removed, native fish have had less floodplain habitat to enjoy. And this has, in part, led to population declines of some of our native fish species. However, scientists and others in the Delta are working together to help create more habitat for native fish. In this picture, you can see an excavator removing dirt to help connect the Delta to a new area of habitat for fish. The hope is that native fish can use these new or improved habitats to help them thrive again. And that concludes my presentation. I just want to say thank you so much for tuning in, and I'm really excited to answer any questions that you guys may have come up with during this talk.
All right, thanks, Nicole. While we wait to see if we have any questions come in from the audience, I have a couple for you. So when you work with the native fish and you work on the floodplain restoration, right? Mm-hmm. You're not the person driving the excavator, right? You're doing something else with the fish? No,
I'm not the one driving the excavator, but we have kind of some different groups of people. Some people, like myself, work on doing the baseline monitoring and looking at the science of what's going on. And then there's whole other groups of DWR that work on all the planning and implementation of those different restoration activities.
Great. So can you tell us a little bit more about what you're doing while you're out there?
Yeah. So what we do when we go out to the Yolo bypass as part of our monitoring program, so the Yolo bypass fish monitoring program that I work for has been going on for, I think since 1998. So it's been going for a long time and helps us keep an idea of what's happening with fish communities and the food web. And so we'll usually go out there. It depends on the time of year, what exactly we're going to be studying. But we use those traps like I showed in the photo. And most of those get serviced daily. So we'll go out to them and check what fish are in them. We identify the fish, we measure the fish, and we record all that data. And then later when we have the chance, we analyze that data for yearly reports as well as scientific studies.
And are you able to go out and monitor fish right now with COVID and the shelter in place?
Unfortunately, all of our field activities were suspended in March because of COVID, which is a bummer because this is a pretty exciting time of the year for the floodplain. Spring is usually when we see a lot of juvenile fish coming out. So a lot of the native fish spawn in the early months of the year, and then the juveniles start to show up about this time. So we are missing a pretty cool time in the bypass, but it's not really safe for us to go out right now because it requires working in such close quarters with our crew.
So one of the questions that came in is, what did you study in school and how did that prepare you for your work with DWR?
It's a great question. When I went to undergrad, I studied environmental science and management, and I emphasized in watershed sciences. And so this kind of introduced me to a lot of different things, both the management side and policy, as well as wetland studies, river studies, fish studies, all those basics. And that really helped me kind of see what was out there and what was available to pursue as a career. And after that, I kind of worked, there's a lot of really neat seasonal opportunities in fisheries science where you can go and work somewhere just for a summer or just for a spring when they're doing special sampling events. So I did that for a while, and it helped me discover what I was passionate about. And I went and got my master's degree in ecology, which helped me really focus on my own personal study. And from there, I was able to start working at DWR.
So did you study fish when you were doing your master's in your undergraduate, or did you just happen to end up with fish?
No, I had decided during those temporary jobs I mentioned that I really liked working with salmon. And so when I went to get my master's degree, I developed a study looking at salmon growth in Sassoon Marsh, which is kind of right in between the Delta and the San Francisco Bay.
Okay. So speaking of salmon, somebody wants to know, why is salmon meat pinkish orange?
That's a good question. It's from what they eat. So when they go out to the ocean and they're eating like different fish and krill, it alters the way their flesh looks. And what's really interesting is that if you catch an adult salmon that's just about to spawn back in freshwater, and you were to fillet that fish, their flesh will be pink or will be white. It's not going to be pink anymore because they've stopped eating all those ocean nutrients. And so that color has actually left.
Wow, how interesting. I did not know that. Why do you like fish so much, or what do you like about them?
I think that I really enjoy working with fish because of two reasons. One being I always have enjoyed being outside and being next to the water or in the water, near the water. That's just where I find a lot of like enjoyment. And it just works out that, you know, if you study fish, then you get to be in those environments all the time. And then I think it's just kind of always been a little bit of a part of my life. I grew up in the San Francisco Bay Area, and my dad had like a small boat for recreational fishing. And so my sisters and I would go fishing with him in the bay and in the ocean. And so it's always kind of been a part of my life that I've been around fish. And it meshed well with my interest in studying the environment and being around water. And yeah.
Okay. So the questions are coming in quickly now. Can you tell us a little bit what your day-to-day schedule was like before COVID, like when you were going out in the field, and is it hard work?
Yeah, that's a good question. My day-to-day schedule for like a week is I would spend 2 to 3 days going out with a small team. It's usually about 3 of us to the field, which is the bypass for us, and doing different fish sampling techniques. And then the other 2 to 3 days, I usually will be in the office, scheduling field crews, attending meetings, writing, analyzing data, those general things. And in terms of the field, I would definitely say it can be hard work. Probably, you know, 3/4 of the time you're out there and it's amazing. It's the best because you're outside and you're hanging out with your coworkers. And it's always kind of a surprise what fish you're going to get. But then if you think about the days where you're cooped up inside and it's raining really hard out, or it's 95 degrees and you're like, oh man, I'm so glad I'm inside. Those are the days that we're outside not liking it quite as much. So I would say people interested in field work should definitely try and get any chance they have to try it out, like through an internship or volunteer opportunity, because it's not for everybody, but it is really exciting and kind of keeps you on your toes.
Do you miss being outside right now or is it a nice day because things heat up?
Definitely missing it right now. This is a really nice time of the year to be out in the bypass. So it's a bummer that we're cooped up, but it's okay.
So it sounds like you like your job, huh?
Yeah, I definitely enjoy this job. The group I work with is really great, and I like being able to both collect the data and then also having the opportunity to analyze it and try and get that information out there so that hopefully there can be more meaningful change made for native fish.
Okay. So I know that you specialize in native fish, but we've had a couple of questions come in about the non-native fish. Can you give us an example of a non-native fish species that it's impacting the Delta? And can you also talk a little bit about how it manages to survive without having the adaptations like the anadromy or the specialized morphology that you talked about earlier?
Yeah, that's a really good question. We have so many invasive species. The San Francisco estuary is one of the most highly invaded estuaries in the world. And a lot of that has to do with the fact that people brought fish because they wanted to fish for them from other areas. So examples of that people might know of are the largemouth bass and the striped bass. And other fish basically made it in on ballast water from ships traveling to and from Asia. And so when those big cargo ships, like they have to pull water in and put water out at varying points along their route. And so they actually transported larval fish into the system. And one of the big reasons that they're able to do so well here is because we've changed the Delta so much from what it used to be. So those native fish were used to variability and having high flows and all these different things and floodplains to take advantage of. And a lot of the fish that we have here now, many of them come from the Mississippi River drainage and some different lake environments where things didn't move as much and were a little simpler. And what we've basically done with our development is really simplified the Delta, put big levees up, channelized everything, and turned it into an environment that looks a little bit more like where the invasive species came from. So it gives them a little bit of an advantage. Also, when they come in, they don't necessarily have predators, so they can kind of go crazy for a little bit before everything else kind of catches up with them.
Great. So one more question. What are a couple of things that people can do to help the environment in the Delta or help the native fish in the Delta?
That's a good question. There's no one simple, easy answer I can give to that because there are a lot of challenges facing fish in the Delta right now. But I think the best thing people can do if they're interested in helping is just learning more about the fish and wildlife of the Delta. It'll help you make more educated decisions about how you want to, what kind of impact you want to have on the environment. And then one thing that's relatively easy to do and helps not just fish, but really all of California would be trying to conserve as much water as you can. Like I mentioned earlier in the presentation, the Delta provides drinking water, water for agriculture, and water for the environment. And that's a lot to parse out. And so the less water we use, the more water that's available for those different groups and the environment.
Oh, wonderful. Thank you. Thank you, Nicole, for sharing your passion for fish in the Delta with us. And I'd like to thank everyone at home for joining us as well today. We will be back next Wednesday at 1:00 p.m. with Rosemary Hartman, another one of our scientists. She's going to be presenting What's Bugging You? Invertebrates of the Sacramento-San Joaquin Delta. So a lot of the little microscopic and small life that lives in the Delta and provides food for Nicole's fish that she works with. In the meantime, if you would like to learn more about California's amazing Delta, you can visit our webpage, water.ca.gov. And for kids at home, we have some fun learning activities at water.ca.gov/education materials. Those are free. You can download them, you can order them, and we are more than happy to send them to you. I want to say thank you again to both Nicole and all of our audience. Please stay safe, and we hope to see you here next week. Take care.